My name is Chamison. My metric number is 2936667. Consider the following national income models. First equation is y equal to c plus I0 plus G0. Second equation is c equal to cyd. Third equation is t equal to ty. Note that y, c, and t are endogenous variables, where I0 and G0 are exogenous variables. All of the above functions can be converted into the following equations. F superscript 1 is y minus c minus I0 minus G0 equal to 0. F superscript 2 is c minus cyd equal to 0. F superscript 3 is t minus ty equal to 0. There are two conditions of the implicit functions theorems are satisfied at the equilibrium points. First condition is the function f superscript 1, f superscript 2, and f superscript 3 have continuous partial derivative with respect to all the variables. Second condition is the Jacobian determinant for the endogenous variables is non-zero at one point which satisfy the equation above. So now we will use the Jacobian matrix 3 by 3 to find the Jacobian determinant. At A11, we will get 1 for the partial derivative f superscript 1 with respect to y. At A12, partial derivative f superscript 1 with respect to c is equal to negative 1. At A13, partial derivative f superscript 1 with respect to t is equal to 0. At A21, we will use the chain rule to find the partial derivative f superscript 2 with respect to y, and we will get negative c prime yd. And A22, partial derivative f superscript 2 with respect to c is equal to 1. And A23, we will also use the chain rule to find the partial derivative f superscript 2 with respect to t, and we will get c prime yd. At A31, partial derivative f superscript 3 with respect to y, we will get negative t prime y. At A32, partial derivative f superscript 3 with respect to c is equal to 0. At A33, partial derivative f superscript 3 with respect to t is equal to 1. So after finding the element A11 until A33, we substitute it into the matrix. Then the next step is cofactor 11 plus cofactor 12 plus cofactor 13 to find the determinant. Then minus 1 1 minus minus 1 2 plus minus 1 3 to find the determinant. So after this doing the calculations, we will get the Jacobian determinant is equal to 1 minus c prime yd plus c prime yd times t prime y, where the c prime yd and the t prime y is between the 0 and 1. So 1 minus c prime yd is positive. C prime yd times t prime y is also positive. So we will get the Jacobian determinant is positive. So the Jacobian determinant is non-zero is satisfied.
My name is Gok Shipei and my matrix number is 296217. For question number B, there's a implicit function that written as y star, c star, and t star. To derive the expression for delta y star over delta g0, delta c over delta g0, delta t over delta g0, using the implicit function rule, we need to differentiate the equation with respect to g0. Hence, the equation can be rewritten as f power of 1 y star c star t star I0 g0 equals to y star minus c minus I0 minus g0 equals to 0. F square y star c star t star I0 g0 equals to t star minus c times yd equals to 0, and f cube y star c star t star I0 g0 equals to t star minus t times y star equals to 0. So to find the partial derivative of y star with respect to g0, we derive the total differential df power of 1 to delta f power of 1 over delta y star times dy star plus delta f power of 1 over delta c star times dc star plus delta f power of 1 over delta t star times dt star plus delta f power of 1 over delta I0 times di0 plus delta f power of 1 over delta g0 times dg0 equals to 0. And after that we collect the terms and holding I0 as constant. After that we divide each term by delta g0 and we will get delta f power of 1 over delta y star times delta y star over delta g0 plus delta f power of 1 over delta c star times delta c star over delta g0 plus delta f power of 1 over delta t star times delta t star over delta g0 equals to negative delta f power of 1 over delta g0. For second question, to find the partial derivative of c with respect to g0, we derive the total differentials df squared to delta f squared over delta y star times dy star plus delta f squared over delta c star times dc star plus delta f squared over delta t star times dt star plus delta f squared over delta I0 times di0 plus delta f squared over delta g0 times dg0 equals to 0. And since y star, t and g0 are not directly dependent on g0, so the equation simplifies to delta f squared over delta g0 plus delta f squared over delta c times delta c over delta g0 equals to 0. And delta f squared over delta g0 represents the derivative of the consumption function with respect to g0, so we can rewrite the equation as delta c over delta g0 times delta c over delta g0 plus delta f squared over delta c times delta c over delta g0 equals to 0. And we simplify the equation, then we can solve it to delta c over delta g0 equals to negative delta f squared over delta g0. For the third, to find the partial derivative of t with respect to g0, we derive the total differentials df cubed to delta f cubed over delta y stars times dy stars plus delta f cubed over delta c stars times dc stars plus delta f cubed over delta t star times dt stars plus delta f cubed over delta I0 times di0 plus delta f cubed over delta g0 times dg0 equals to 0. And we collecting terms holding I0 for constants and divide each terms by delta g0, and we will get the answer. It's delta f negative delta f cubed over delta g0. So that we convert it into matrix form, become 1 negative 1 0 negative c prime times yd 1 c prime times yd negative t prime y 0 1, and the other matrix is delta y stars over delta g0, delta c stars over delta g0, and delta t stars over delta g0, and equals to 1 0 0.
A very good day, sir. My name is Teo Yan Chi and my metric number is 292861. Now let us continue for our part B to find our J1. To find J1, we can use Cramer's rule to find it. Then our J1 will be, for the first column will be 1, 0, 0, and the second column is negative 1, 1, 0, and the third column is 0, C prime ID 1. Then J1 equals to C11 plus C12 plus C13. Then putting our first row in front of our C11, C12 and C13, then we will get J1 equals to 1 multiplied by 1, 0, C prime ID 1 minus multiplied by negative 1 multiplied by 0, 0, C prime ID 1 and plus 0 multiplied by 0, 0, 1, 0. Then we will get J1 equals to 1. After that, we can find our delta Y star divided by delta G0, which is equal to J1 per J. Then we will get 1 per 1 minus C prime YD plus C prime YD multiplied by TY, which is bigger than 0. Let us find J2, same as using Cramer's rule like J1. Then we will get J2 equals to 1 minus C prime YD minus T prime Y, 1, 0, 0, 0, C prime YD 1. Then putting the first row in front of C11, C12 and C13, then we will get J2 equals to 1 multiplied by 0, 0, C prime YD 1 minus 1 multiplied by negative C prime YD, negative T prime Y, C prime YD 1 and plus 0 multiplied by negative C prime YD, negative T prime Y, 0, 0. After calculate it all, C11, C12 and C13, then we will get J2 equals to C prime YD minus C prime Y multiplied by T prime Y. Then we can calculate our delta C star per delta G0, which is equal to J2 per J. Then we will get C prime YD minus C prime YD multiplied by T prime Y per 1 minus C prime YD plus C prime YD multiplied by T prime Y. Let us continue to find our J3, same as J1 and J2 with using Cramer's rule. Then we will get J3 equals to, for the first column is 1 negative C prime YD, negative T prime Y, and the second column is negative 1, 1, 0, and the third column is 1, 0, 0. Then J3 equals to C11 plus C12 plus C13. Then putting our first row in front of C11, C12 and C13, then we will get J3 equals to 1 multiplied by 1, 0, 0 minus multiplied by negative 1 and multiplied by negative C prime YD, negative T prime Y, 0, 0 and plus 1 multiplied by negative C prime YD, negative T prime Y, 1, 0. Then after we calculate all C11, C12 and C13, then we will get J3 equals to T prime Y. Finally, we can find our delta T star per delta G0, which is J3 per J. Then we will get T prime Y per 1 minus C prime YD plus C prime YD multiplied by TY, which is bigger than 0.